Hello all, this is Nandini, Assistant Professor, Department of Computer Science at Dr. S.N.S. Rajalakshmi College of Arts and Science. Now we are going to discuss about digital data communication techniques in computer networks and data communications. So let's discuss. The digital data communication techniques are classified into different types. So there are synchronization, asynchronization, error detection and error corrections. So these are the techniques come under digital data communications. So the first one is synchronizations. So basically the stream of bit is transmissions from one device to another device, so which across transmission link, and it involves a great deal of cooperation and agreement between the two sides. So one of the most fundamental requirement is synchronization. So in this process, the receiver must know the rate at which bits are being received so that it can sample the line at appropriate intervals to determine the value of each received bits. And the asynchronous transmission is each character of data is treated independently, and each character begins with start bit that alerts the receiver that a character is arriving. And next one is error detection, so which is performed by calculating an error detecting code, so which function is function of the bits being transmitted, and the code is appended to the transmitted bits, but the receiver calculates the code based on the incoming bits and it compares it to the incoming code to check for errors. And next one is error corrections, so which is similar to an error detection, but it is capable of correcting certain errors in a transmission bit stream. And next one is asynchronous and synchronous transmissions. So basically the data are transferred over a single signal path rather than the parallel set of lines, so which is common with input output devices and internal computer signal path. So with the serial transmission, signals elements are sent down the line one at a time, and the each signal elements may be less than 1 bit or more than 1 bit. So less than 1 bit is example for Manchester coding, and the 1 bit is example for N or ZL and FSK or digital and analog signals, and more than 1 bit is example for QPSK. And next one is asynchronous transmissions. So this is the first, it is called oddly enough asynchronous transmissions. The strategies with this scheme is to avoid the timing problem by not sending long and uninterpreted streams of bits. So instead of, the data are transmitted one character at a time, where each character is 5 to 8 bits in the length, and the timing or synchronizations must only be maintained within the each character, and the receiver has the opportunity to resynchronize at the beginning of each new character. So this is called asynchronous transmission. And next one is synchronized transmissions, so which means a block of code is transmitted in a steady stream without start and stop codes, and the block may be many bits in length, which prevent timing drift between transmitter and receiver. So their clocks must somehow be synchronized. One possibility is to provide a separate clock line between transmitter and receiver. So the one side is transmitter or receiver pulse, and the line regularly with one short pulse per bit time. The another side is using this regular pulse as a clock. So this is called as a synchronous transmission. And next one is types of error. So in the digital transmission systems, an error occurs when a bit is altered between transmission and receptions. So that is, a binary 1 is transmitted and the binary 0 is received, or a binary 0 is transmitted and a binary 1 is received. And this error is classified into two types. There are single bit errors and burst error. So the single bit error, which is nothing but it is an isolated error, and this condition of the error that alters 1 bit but it does not affect nearby sites. And the single bit error can occur in the presence of white noise when a slight random deterioration of the signal to noise ratio, and it is sufficient to confuse the receiver's decision of a single bit. And next one is burst error. So the burst error length of B is contiguous sequence of B bits, and which the first and last bits and any number of intermediate bits are received in error. And the burst errors are common and more difficult to deal with, and the burst error can be caused by impulse noise. So these are the types of errors. And next one is assessment. So the assessment are explain digital data communication, and second one is define errors and explain its types. These are the reference. Thank you.